All right, well, I hope you had a good test yesterday. We are going to do final exam review. Final exam review. So go ahead and take out your notebook, and we're going to do the final exam review in your notes. Basically, what I want you to do is I want you to work some of the problems. And so if you'll work these problems in your notes, then that'll be great. Uh, all this stuff is in your notes, and so you only need to practice in your notes, okay? You don't need to write everything. I mean, all this stuff is there. I'm going to, once we get close enough to the final exam, I'll remind you of all these things again, but we simply want to review. All right, so first off, let me review some of the basic properties. And again, you don't need to write this in your notes. Okay, so I'm talking about the commutative property, the associative, those kinds of things. All right, so when you think of the commutative property, what one word comes to mind? And I hope it would be the word order. You can change the order, right? A plus B equals B plus A. We can swap the order. And you can do that with addition, or you can do that with multiplication, right? Order. Associative property, the associative property. And I hope with the associative property you think about the word grouping. The associative property and grouping. So normally it looks something like this, where the B and the C are grouped together. Now we'll change the grouping and have the A and the B grouped together. And again, you can do it for multiplication as well. The next property is the identity, and hopefully you remember with identity you get back to the think it, and hopefully you're thinking original. So the identity gets you back to the original. So that would be something like this. A times 1 equals A. 7 plus 0 equals 7. Gets you back to the original, right? We started with an A and we end up with an A. We are back to the original. And then, of course, you've got the inverse property. The inverse, you're either going to add inverses or multiply by the inverse. That's a little bit different. Add inverses. The inverse of an A is a negative A, and you end up with 0. To multiply inverses, the inverse of multiplication is a 1 over A, and you get 1. So inverses, adding, you add the inverse and you get 0, the identity element, and you multiply and you get 1, the identity element of multiplication. All right, and then we have the distributive property. We've used that a lot, and hopefully you remember that one. You're going to distribute the A times the B and then the A times the C for an AB plus AC. So A times the quantity B plus C equals AB plus AC. All right, so those are the basic properties. Don't forget there are a few more that we talked about, and so let me review those with you as well. That would include the symmetric property, and basically the symmetric property is you can swap sides. So the symmetric property would be something like this. If 3x plus 2 equals 7, then 7 equals 3x plus 2. So for any equation, you can take the left side and put it on the right side and put it on the left. The reflexive property is kind of boring. It's just you get back the same thing. So reflexive is something like this. 3x equals 3x. You might think that looks like the identity property, but that's a reflexive. A 3x equals a 3x. Kind of boring. And then the last two are the multiplication and addition equality properties. The multiplication or addition equality property. So let me start off with a basic equation here, and I'll show you both at once. Okay, so the addition equality says you can add the same quantity to both sides and not change the fact that you have an equality. And the multiplication equality says you can multiply both sides by the same quantity and not change the fact that you have an equality. All right, so those are our basic properties, and hopefully you'll remember them for our final. Next is rules, and the rules are important. Let's first off review the fraction rules. All right, it is of utmost importance that you keep in mind that to add fractions, you must have a common, and hopefully you're thinking, denominator. So a over x plus b over x means what do? You add the numerators and put them over the common denominator. And remember, we started doing this plus or minus. So this would be plus or minus. So if it was a over x minus b over x, you'd get a minus b over x. Okay? Adding fractions, you must have a common denominator. So what happens when you have something like this? 5 over a minus 3 over b. Well, your thought should be, I need to get a common denominator. And how would you do it in this problem? You would multiply the left fraction. You need a b on the bottom, so you can multiply it by b. Whatever you do at the bottom, do the same thing at the top. The right fraction, you need an a on the bottom, so you can multiply it by a. Whatever you do on the bottom, do the same thing on the top. And now you're going to add the numerators, 5b minus 3a, and put them over the common denominator. And remember, in the bottom, we're going to put them in alphabetical order. Some would even want to do that in the top. You can, but it's not absolutely necessary. So that's adding or subtracting fractions. Got to have a common denominator. All right, well, what about multiplying? A over b times c over d. Well, don't forget this when multiplying. Arbum. All right, we've been through that a lot. Always look to reduce before you multiply. All right, so, and then once there's no reducing, and this one has none, it's going to be top times top, bottom times bottom, top times top, bottom times bottom. But always look to reduce before you multiply. So a quick example, 10x over 7 times 21 over 4x. Okay, there's reducing here, right? Our 21 is a 3 times 7. We can divide out the 7s. We can divide out the x's. All right, and then our 10 is a 2 times 5, and our 4 is a 2 times 2, and we can divide out one of those 2's. Now we can finish off multiplication. 5 times 3 is 15, with a 2 over on the bottom, and you have 15 halves. All right, multiplying. Then, of course, there's dividing of fractions. And so the rule would go like this: a over b divided by c over d. And remember, you must invert the second fraction. Change the division sign to multiplication. So you're doing the reciprocal of the second. And remember, on this step now, reduce before you multiply. Reduce before you multiply. Reduce before you multiply. Very, very, very important. Okay, some of the exponent rules. All right, do you remember basic x to the a times x to the b? And hopefully you're thinking that's x to the a plus b. How about a problem like this? What is y to the 2x times y to the 5 minus 2x? Y to the x times y to the 5 minus 2x. Well, if you follow the pattern, what are you going to get on this? Go ahead and try it for a minute. All right, and hopefully you said y to the 2x plus, right, plus sign, 5 minus 2x. Look, this thing can be simplified. We can add like terms. A positive 2x and a negative 2x is 0. And this thing ends up being y to the 5th. Okay, so multiplying like bases. Multiplying like bases. Next rule is x to the a to the b. And hopefully you're thinking the answer is x to the a times b. X to the a times b. Remember, you get in trouble in a couple places. Let me give you 2 examples of this kind. If we had 2x squared cubed, in this situation, we must distribute this through the multiplication times both exponents, even though the 1 is not shown for the 2. So this is going to be 2 cubed times x to the 6, and you should change 2 cubed into a number. 2 times 2 is 4, times 2 is 8, so 8x to the 6th. Be careful with a problem like this. How about this kind of a problem? Negative 2 times the quantity x squared cubed. Well, remember, in this situation, the exponent only applies to what's below and to the left. And so that exponent has nothing to do with that negative 2. So this ends up being negative 2 x to the 2 times 3, or x to the 6, and that one's a negative 2 x to the 6th. All right, exponent to an exponent. All right, then we also have x to the a divided by x to the b, and hopefully you remember the rule is x to the a minus b, right? X to the a minus b. Where do you guys get in trouble in rules like this? How about something like this? How about x to the 7th divided by 3x to the 4th? Well, again, remember, the exponent only applies to its base. So that 3 doesn't go anywhere. So your top ends up being x to the 7 minus 4. That's the top. And you still have that 3 in the bottom. Where do we end up? X cubed over 3, and that's the answer. That's as far as you can take that. You can't go any further. So be careful with something like that. What else? Anything to the 0 power. Do you guys remember why 7 to the 0 power equals 1? All right, remember, the 0 power means the base divided by itself. Any base divided by itself is 1. How do you get yourself in trouble in a problem like this? Something like this. 3 times the quantity xy squared to the 0. Well, again, remember, the exponent only applies to its base. This is a 3 times an xy squared to the 0 power, which is what? An xy squared over an xy squared. And the box becomes a 1, but 3 times 1 is 3. So be careful on a problem like that. Be very, very careful on a problem like that. All right, don't be surprised if you have to multiply out a difference of 2 squares, something like this. A minus 2 times the quantity a plus 2. And so you can do the shortcut, or you can multiply it out longhand. If you know it's a difference of 2 squares, you know it's going to be an a squared minus 4. If you don't remember it's a difference of 2 squares, then you're just going to multiply it out longhand. You're going to distribute a times a squared. A times positive 2, positive 2a. Negative 2 times a, negative 2a, negative 2 times positive 2, negative 4. What happens in the middle? A positive 2a and a negative 2a end up at 0, and you get a squared minus 4. Difference of 2 squares. So be aware of those. Look for those. Expect those. One other rule. Don't forget something like this. If you had a 10 plus x over a 5, remember, you cannot reduce this 10 and this 5 like that. Because remember, the 10 on the top is tied to the x by addition. However, you can do our division rule and split this up into 10 divided by 5 plus x divided by 5. Now you can reduce the 10 and the 5, and the answer to this would be 2 plus x over 5, and that's as far as you can go with it. All right, our next chapter is going to be on radicals, and so expect radical rules on the final exam as well. Radical rules, but we'll go over those when we get to next chapter, right? So the rules section. You know, we've had a rules section every test. You should expect a rules section on your final exam. All right, let's do some problems. All right, I'm going to start out with some basic fractions because, again, they're the key to everything. We got to know how to deal with them. So how about a problem like this? Negative 7/12 minus 3/20. All right, see what you can do with that. Negative 7/12 minus 3/20. Just going to give you just a couple minutes here. See what you can do with that. Remember, it's best to multiply by the lowest common denominator, it's best to get the lowest common denominator. Sometimes that's not so clear, and factoring can make it clear. This is a 4 times 3. Now, I could go further, but that's all I need to do because a 20 is a 4 times 5. So notice they both have 4s. What is the 12 missing that the 20 has? And that's a 5. So I'm going to multiply it by 5 over 5. What is the 20, the 4 times 5 missing that the 12 has? And that's a 3. So I'm going to multiply it by 3 over 3. This way I'm going to get the lowest common denominator, which is a 60, right? So now remember, we're going to multiply the numerators, negative 35 minus 9 over the common denominator. And I can leave it factored for right now. It's a 3 times 4 times 5, or I can write 60. But remember, if it reduces, I'm better off in factored form. All right, let's add those numerators. 35 negatives and 9 more negatives is a negative 44 over a 3 times 4 times 5. Oh, yeah. Oh, this is going to reduce, right? So we have a 4 times a negative 11, right? This is a 4 times a negative 11. And now I can see clearly those 4's reduce. What is my final answer? Negative 11 fifteenths. Okay? Adding fractions. You gotta have a common denominator. Add the numerators and put them over a common denominator. Add the numerators and put them over a common denominator. All right, remember, multiplying, dividing fractions, reduce before you multiply. Let's do a real simplistic problem. How about something like this? 8x divided by 6/5. 8x divided by 6/5. All right, see what you can do with that. 8x divided by 6/5. All right, hopefully you're thinking, change division to multiplication and invert the second one. For clarity's sake, I'm going to put that 8x over a 1. All right, and hopefully you're thinking, let me get rid of these double lines here, fraction bar. All right, hopefully you're thinking, reduce before you multiply, and you should see the reduction here with an 8 and a 6, and clearly those 2's divide out. And so that's it though. And so what are we left with? 20x over 3. And that would be the answer, and you're rolling on. All right, one more. Sometimes you'll have a compound problem. How about something like this? 1/2 plus 1/3 divided by, oh, I don't know. Let's go with 5/6. Okay, we have to follow the order of operations here. We've got to do this addition first. In order to do this addition, we've got to get a common denominator. So I'm going to multiply this by 3, whatever I do on the bottom, do the same thing on top. And this one by 2, whatever I do at the bottom, do the same thing on top. Okay, what is my left side going to become? Add the numerators, 3 plus 2, and put them over the common denominator. And now this is divided by 5/6. And so look, we ended up with 5/6 divided by 5/6. All right, so this is 5/6 divided by 5/6. I just made this problem up off the top of my head. And so the 5's divide out, and the 6's divide out. And what's left? Nothing? No. Well, remember, 5 divided by 5 is 1. 6 divided by 6 is 1. 1 times 1 is 1. And look, isn't 5/6 divided by 5/6 1 anyhow? Of course it is. And so the answer there would be 1. All right, let's go on to some equations. Hopefully at this point we're quite good with our equations. Let me give you just one simplistic one to get you going, and then we'll do a little bit more challenging equation. How about this? Negative 2x over 5 minus 3 equals 7. All right, can you solve that? Minus 2x over 5 minus 3 equals 7. All right, see what you can do with that. Right, so hopefully you're thinking when things are both added to and multiplied times a variable, move things added first, right, as we try to isolate our variable. So hopefully you're going to add positive 3 to both sides. And you got negative 2/5 x equals 10. Now things multiplied times the variable. You move by multiplying both sides by the reciprocal. Okay, on the left, the negative 2's divide out, the 5's divide out, leaving us our x all isolated. And be careful on the right, right? Arbum, reduce before you multiply. This 10 is a 2 times 5. And let's think about the sign. Before I divide out those 2's, we have a positive divided by a negative. What's our answer going to be? Negative. Don't forget that. Don't miss that. All right, and then these 2's are going to divide out. We end up with 5 times 5 is 25 on the top, and we end up with a negative 1 on the bottom, but I've already taken care of that negative, so I end up with negative 25, right? If you did it the other way, you would have gotten 25 over negative 1. You wouldn't leave the 1 on the bottom. You would say x equals negative 25. Okay, simplistic equations. But remember, we can now kind of make them a little bit more interesting. So let's go to an equation that's a little bit more challenging. How about something like this? 3x minus 2 equals 5 minus 2 times the quantity 4x minus 3. Okay, so we have a couple things with this equation, right? We have some distributing, and we also have the variable on both sides. All right, see if you can solve this. See if you can solve it. Order of operations. Be careful. Okay. So hopefully you got to this step, you distributed. What would you do next? Hopefully now you decided, hey, I'm going to get all my variables on one side. And how do you move either the 3x from the left to the right? You add its opposite. How do you move the negative 8x from the right to the left? You add its opposite. My choice is always to end up with a positive variable, so I'm going to move the negative 8x by adding its opposite to both sides. All right, what do we get on the left side? We get 11x. We still have minus 2. The right, the negative 8x and the positive is gone, and I can add the 5 and the 6, right? That's 11. Okay, now it's a simplistic equation. And hopefully you solve from here. Let's move the 2 by adding its opposite to both sides. So we got 11x equals 13. Multiply both sides by the reciprocal or do the shortcut. We'll divide both sides by 11. We get x equals 13/11. All right, hope you got that right. That's about as hard as they're going to get in that respect. It's about as hard as they're going to get in that respect. Remember what happens when you have fractions. So let's look at a problem like this. How about 3n over 2 plus 3/10 equals 4/5? Okay, well, we can deal with the fractions if you want. You can really just add a negative 3/10 to both sides and then move the 3/2 by multiplying by the reciprocal, and you can do that. Or you can get rid of the fractions by using the LCD. That's the preferred method because as we get more complicated, and we will 2 chapters from now, we'll be having polynomials on the bottom. So it's better to learn the method that solves everything, and that's to multiply through by the LCD over 1. We've already done these. And so what is the LCD? Hopefully you agree the LCD is 10. So I'm going to multiply this one by 10 over 1, this one by 10 over 1, and this one by 10 over 1. Everything on the left by the LCD, everything on the right by the LCD. And if you did everything right, those denominators are going to go away. They're going to divide out. And you can see there's no denominators left. Look where we end up. 15n plus 3 equals 8. Hey, that's an easy problem to finish, right? Add a negative 3 to both sides. Divide both sides by 15. What are we going to end up with? 5 divided by 15, and n equals what? 1/3. All right, so that kind of a situation, not too hard to deal with. All right, how about an equation like this? Do you remember these? The absolute value of 2x minus 5 plus 4 equals 18. All right, what you have to remember is there are two ways to solve these problems. There are two ways to solve these problems. Now, one way is to isolate the absolute value and then deal with the plus and minus. That's a good method. I like to instead deal with it just in its current form, because then we can solve inequalities as well. Okay, so what does that mean? You have to remember there are two solutions to an absolute value problem when the variable is located inside the absolute value. Let me just refresh your memory. Right hand side. If we had the absolute value of x equals 4, what values of x would yield a 4? Well, one answer would be the absolute value of 4 is a 4. But there's another solution as well. The absolute value of negative 4 is also 4. So see how there are two possible values for the x, a positive 4 and a negative 4. And what we have to do in our math is find both solutions. All right, so what was our method? Our method was simply replace the absolute value with a parentheses and solve. That will give you one of the two solutions. Okay, so replace it and solve. All right, so what does that mean? This is a negative 1 when you add them up, so I'm going to add a positive 1 to both sides. I end up with 2x equals 19. Let's divide both sides by 2, and we end up with x equals 19/2. That's one solution. How do you get the other? Again, remove the absolute value symbol, replace with a parentheses, and put a negative in front of that parentheses. Now again, why do I do it this way? I know a lot of books teach to put the negative on the other side, but you have to isolate the absolute value first to do that. So that's one thing you have to remember in that methodology. In this methodology, you don't. And the other thing is this. For solving inequalities, if you do it the other way, you have to remember to reverse your inequality symbol, whereas this way it reverses for you automatically. All right. Anyhow, there's merits to both ways. I prefer this method. All right, so we got to distribute the negative. So we have a negative 2x plus 5 plus 4 equals 18. So now this is really a positive 9, so we'll add a negative 9 to both sides. Negative 2x equals 9. We'll divide both sides by negative 2. And our second solution is going to be x equals negative 9/2. And there are two solutions. Absolute value equations. Don't forget them. You have to remember how to solve them. Don't forget them. You have to remember how to solve them. And that brings us to inequalities. Inequalities. All right, how do you solve inequalities? Well, just like equations, right? But there's one exception. There is one exception. There's one exception. All right, so what I want you to do is I want you to solve this in graph. Solve and graph. Okay, your graph can be just a simplistic graph, but you have to solve and graph. All right, so here's the problem. 10 greater than negative x over 5, negative x over 5 minus, let's go minus 8. No, let's go with minus, let's keep it easy, let's go minus 5. Okay, 10 greater than negative x over 5 minus 5. All right, go ahead and solve that and graph it. And I'll show you the number line that you need to graph it on while you're working the problem. Okay, go ahead and solve that and then graph it on that number line. Ooh, faulty thinking there. We better fix that. How about this? That's much better. All right, graph it on that number line. Okay, so if you go to isolate the variable, you're going to add a positive 5 to both sides. You're going to get 15 greater than negative x over 5. Things multiply times the variable. You move by multiplying both sides by the reciprocal. We have to do a 5 over negative 1. And remember, whenever we multiply by a negative, what do we do with the inequality symbol? We reverse it. I end up with negative 75 less than x. Negative 75 less than x. Okay, so that solves the inequality. That's not the best way to graph. So what did I tell you to do when you have the number on the left and the variable on the right? I told you to switch sides. But I said when it's an inequality and you switch sides, what else do you have to do? And hopefully you remember that's the other time you have to reverse the inequality symbol. So we get x greater than negative 75. How do you do that? Greater than. It's not greater than or equal to. It's just greater than. So that's an open circle over the 75, meaning the negative 75 is not included. An arrow the same way as the inequality symbol to the right. And so this is any value bigger than negative 75. All right, inequalities. Inequalities, inequalities. Don't forget them. Don't forget them. With all this comes conjunctions and disjunctions. All right, we've gone through that, and absolute value inequalities, conjunctions and disjunctions, and absolute value inequalities. Hopefully you remember that a conjunction is joined by the word and, where the solution is the what? Intersection. Intersection of the two inequalities. Because a disjunction, by the way, the intersection symbol, whoops, is like that. A disjunction is joined by the word or, where the solution is the union of the two inequalities, and the union symbol is like that. And remember, the symbol can replace the word and, the symbol can replace the word or to tell you that it's a conjunction or a disjunction. And so you're going to have to go back and review how to go about figuring out the solution to a conjunction or a disjunction. And that's a whole day in and of itself. So I'm not going to review those right now. That's a whole day. In that then comes solving inequalities, absolute value inequalities. And so if you remember, you have to remember how to determine whether it's a conjunction or disjunction. You can do it by the solution, or you can do it based on the inequality symbol. So conjunctions, when the absolute value is isolated, if it's a less than or a less than or equal to, then it's going to be a conjunction and the solution is the intersection. Disjunctions is going to be a greater than or equal to. Okay, disjunction, the solution is going to be the union. All right, again, I'll go over all those things with you as we get closer to the final, but you're going to have to review conjunctions and disjunctions. All right, conjunctions and disjunctions. All right, we got time for a little bit more. Let's do some functions. Functions. All right, remember, don't let functional notation scare you. Functional notation is just a simplistic way of getting you solved. How about try this? Solve this. Go ahead and solve that. F of negative 2 equals x squared minus 4x plus 2. F of negative 2 All right, so hopefully you said I've got to substitute in the negative 2 everywhere where the x is. So I just put parentheses everywhere where the x is, and I put in that negative 2. Front term, negative 2 times negative 2, positive 4, right? Middle term, negative 4 times a negative 2 is a positive 8 plus 2. 12 and 2 is 14, and f of negative 2 is 14. Now remember, if we were graphing this, this represents a pair, right? An ordered pair. And so the ordered pair is when the x is negative 2, the y is the 14. Which then means we can go through and review some terminology, right? Remember, the x is the independent variable. The y is the dependent variable. All the possible x values form a set called the domain, and all the possible y values form a set called the range. All right, we'll get into more of that a little bit later. Okay, so functional notation. What would you do if they said to you, put this into functional notation? 7x plus y equals 11. What if they said, put that into functional notation? What would you do? Go ahead and see what you can do. See if you remember how to do that. All right, functional notation, right? You need to isolate the y. Get the y all by itself on one side of the equal sign. How do you do that? Let's move the 7x. I get y equals negative 7x plus 11. And remember, all you simply do is replace the y with the f of x, the functional notation. So f of x equals negative 7x plus 11. And you have put that problem into functional notation. You've put that problem in the functional notation. All right, how about something like this? What if you had f of x equals, and now we have a brace. And we've got these sets of points. 2, 4, 3, 7, 5, 4. All right, so we can do a couple things from this. First off, I can ask you the domain. Remember, the domain will always be listed in set notation. Can you list the domain for me? What is the domain? All right, hopefully you're thinking all the domain are all the x values, so hopefully you said 2 and 3 and 5. All right, 2 and 3 and 5. All right, so what is the other set called? What is the set of all the y values called? And hopefully you're thinking range. All right, so what would be the range? 4, 7. Do I list the 4 a second time? No, you don't repeat anything. 4 and 7 is the range. So we have a domain of 2, 3, and 5. We have a range of 4 and 7. All right, so here's the question. Is this relation also a function? Or is it just a relation? Is this a function, or is it just a relation? Yes or no? Is it a function, or is it just a relation? Hopefully you said this. It is a function. Remember, any given input, x value, gives you a definite output. If you input 2, does it know what to give you? Yeah, 4. If you input 3, does it know what to give you? Yeah, 7. If you input 5, does it know what to give you? Yeah, 4. Any given input gives a definite output. In the way I taught you guys, help you remember, any guy can only date one girl. Now, girl 4 is dating 2 guys, but that's okay, because guy 2 is dating girl 4 and nobody else. Guy 3 is dating girl 7 and nobody else, and guy 5 is dating girl 4 and nobody else. That's okay, it works. That is a function. All right, one last thing. Do you remember how to tell if a graph is a function? This is a sine wave, and it keeps going. Is that sine wave a function? Yes or no? Do you remember the test? It's got to pass a test. And that test is the vertical line test. So it's got to pass the vertical line test. Is there a vertical line that hits more than one point? Does there exist a vertical line hitting more than one point? The answer is no. So yes, it is a function, which means any one guy is dating only one girl, which means any input gives you a one definite output. All right, that's all the time I have. There are students at the door waiting to come in, so I'm going to leave it at that.